continue with the next category of problems under relations. Now, all this while we were doing relations between pairs of elements, like one element x related to another element y. Now we will do numericals where you will have pair of elements related to another pair of elements, suppose xy and uv. Okay, so these category of problems are what we are going to discuss now. The first question under this category is, suppose the question is, show that the relation R on the set A, which is equal to set of integers such that 0 less than equal to x less than equal to 12. That means it is defined on the set of integers lying between 0 and 12, and it is given by R, which is equal to the pair AB related in such a manner that A minus B modulus is multiple of 4. Okay, is multiple of 4. You have to show that is an equivalence relation. Okay, so this is the next question. I am just recapitulating first where we are doing this category of problems. Here, of course, we have a pair. A is related to B by the property this. Okay, so so therefore we have let's work it out. Solution. What are the elements of A? If you want, you can list it. If you don't want, don't list it, no problem. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is the set of elements of the set A. And R definitely is a subset of A cross A. We know R is what? R is the ordered pair of elements. First thing, what do we have to show on the equivalence relation? We have to show that R is reflexive. Okay, that is, I have to show that A is related to A, or I have to show that AA is an element of R. This is what I have to show. So let me check what is AA. Now for any element A belonging to the set A, I know that mod of, if I check this property, mod of A minus A is 0, right? Mod of A minus A 0, which is definitely a multiple of 4, isn't it? Which is a multiple of 4. So this means that the pair AA belongs to R. So therefore we can say that R is reflexive. Next we will show that whether it is symmetric or not. To show that R is symmetric, that means what will we show? That A is, if A is related to B, then it will mean that B is also related to A. In other words, we will show that if the pair AB belongs to the set R, the relation R, then the pair BA also belongs to the pair R, to the set of relations R. Okay, this is what we will show. So therefore, we will take a pair and check and see. In fact, we can do it in general, or you can take particular numbers from here and proceed. The best thing is, if you can show it in general, then please show it in general itself. Okay, don't take particular examples, because there can be exceptions. One pair may be there which does not satisfy this property. So in that case, it will deviate from the rules that we have. Okay, so therefore, now AB belonging to R, what does it mean? If I'll take that, if AB belongs to R. What does it imply? It implies modulus A minus B is a multiple of 4. You can take a particular case, that is modulus of A minus B is equal to 4 lambda, where lambda is a integer. Okay, integer, or you can say it is a natural number, or you can say it's a whole number, whatever. Okay, so therefore what shall we do? Now check what is B minus C. If this is 4 lambda, therefore this means modulus of minus B, this implies modulus of B minus A, or rather I will write it separately. We'll stop over here. Then what is modulus of B minus A? It means that it is minus of A minus B. This in turn itself means it is mod of A minus B, and therefore this is also 4 lambda. Okay, therefore B minus A modulus is multiple of 4 if A minus B modulus is multiple of 4. What does it mean? Thus, if AB belongs to R, then BA also belongs to R. And this means that R is symmetric. Okay. So now what will we do? Now we will see whether it is transitive or not. Okay, so we have seen that it is symmetric. Now we will see whether it is transitive or not. That means what will we check? Let's write that. Subpart 3 is we will show that R is transitive. That is, what do we have to show? That is, we will show that if AB belongs to R, or rather I'll write both ways, if A is related to B and B is related to C, then it implies that A is related to C. In other words, that is, if AB belongs to R and BC also belongs to R, then I will show that AC also belongs to R. This is what I will show. Okay, this is my RTP. So therefore, let's assume that AB belongs to R and BC belongs to R. And then what do we get? I will rub this line out as well as this. So therefore, let AB belong to R and BC belong to R. What does it mean? This means that mod of A minus B, I hope you can see, yes you can. This means that mod of A minus B will be multiple of 4 and mod of B minus C is also multiple of 4. In other words, it means suppose mod A minus B is 4 lambda and mod of B minus C is for some other constant k, where k and lambda are constants. Okay, constants. And of course, you can also write that lambda k belongs to W, whatever. Okay, W means whole numbers because 0 can also be there. That is one. So therefore now we will check what is A minus C modulus. Now mod of A minus C, we want to introduce these two. So A minus C, I am writing it as A minus B plus B minus C. Easily we can write this. Okay, and if we are writing this, then we have a property of modulus, if you remember, that mod of x plus y is less than equal to mod x plus, can you see? No, you cannot see. We have a property that mod of x plus y is less than equal to mod x plus mod y. If you can remember this, it will be nice. Then we will apply this directly. Okay. or you can do one thing, you can separate them. Okay, you can separate them and you can write it as this is equal to, I'll do one thing, I'll make it easier. Instead of using, suppose you don't know this property, then how will you proceed? Okay, then you can do one thing, then a minus b, it becomes either positive or negative of 4 lambda. I'm removing the modulus sign, and this also means that b minus c is plus minus 4k. Okay, so therefore what will you write? In that case you will write then a minus c. Suppose you don't know this, I'm leaving it out. Okay, suppose you don't know this property, then you proceed like this. A minus c. Now a minus c, which can be written as, this part I'm keeping the same, as a minus b plus b minus c, and therefore it can be replaced. A minus b is plus minus 4 lambda and this is plus minus 4k, just replacing the previous two equations. In other words, it is plus minus 4 lambda plus k. Lambda and k are constants, so definitely what can you say? Therefore mod of a minus c is equal to 4 lambda plus k. Okay, right, like this. And which means that this implies that a minus c is multiple of 4, and this means hence if AB belongs to R, or here itself you write, which implies that AC belongs to R. Finally, you write the conclusion. That which conclusion will you write? This last line over here, I'm just rubbing out the rest. Thus, this will be your conclusion. This one. Thus, if AB belongs to R and BC belongs to R, then it implies that AC also belongs to R. And hence, what is R? Therefore, R is transitive. And final sentence will be that since it satisfies all these three properties, therefore R is an equivalence relation. That is, finally you will write combining 1, 2, 3, we have R as an equivalence relation. Okay, so combining this, we can say that R is an equivalence relation.